let us solve these questions involving the applications of De Morgan's laws. So these are involving simplifying instead of proving, and these are one of the most common questions. They'll tell you to simplify. They just want to see how you can apply the De Morgan's concept. Okay, so let's begin with this question. I think these are one of the simplest questions, though they come sometimes. They like doing them on tests, and one of them maybe might come. Okay, so now let us now proceed. So they have said that if C is a subset of D, you see, so what they are trying to say is that assume, let me represent this on a Venn diagram. Yeah, imagine, should try to assume that we have so they have said that C and D are, I mean C is a subset of D, meaning C is in D, so the whole C is contained in D. For the fact that they have said it is a proper subset, as you can see, there is no equal sign here, there is no equality, so meaning it is something like this, meaning that there is this set, an oval shape, something like that. So there is this set which is D, then inside set D there is set C, you see. So the set C is contained in set D, making it a proper subset of D. Okay, so now on the first question they want us to find the intersection of C and D. Intersection meaning they want us to find the values that are found in both C and D. So these values meaning that these values are okay, let's say maybe we have numbers 2, 3, 1. Which value would that be? The value that is in both C and D. Is it 3? Because 3 is not in C, so meaning it is 1. Where is this element 1? It is in C, right? So meaning that this the answer here is C. So you are going to say is set C, because that is where we're going to find all the values that are found in both C and D. Okay, as simple as that. On the next question, so on the next question, question 2. So on question 2 now, we have been given C complement union D. So when you're given something that is in this format, you should try to simplify it by reversing that De Morgan's concept. So this one can also be written as C, meaning this is going to change D. So it can also be written like this. So now, where can we find the elements that are between C and D, that are found in both C and D? It is A, right? C. So you're going to say C complement. This is the simplest form in which you can leave this question. So now let's go to 3. So 3, they're saying that we need to leave this in simplest form, C union the complement of D. So the simplest form in which you can leave this one is to simply just leave it like this. It cannot be simplified any further, as they have even said in the question that if possible, meaning it's not always it's going to be possible for them to be simplified. If you can't simplify it any further, it means you just leave it like that. Okay, so let's move on to the next question. Let us move on to the next question 3. Oh, this was 3. So right now we're on question 4. Okay, so question 4 is like this. C complement. C complement. We have C complement section. C U union. Okay, so now I hope you remember the concept of distributive law. So as you can see, we have three differences. These are different. This is C complement, this is just C, and this is D, and the symbols are different, right? So the moment you just see this, you need to expand it. You need to expand it by multiplying this with this and this with this, separated by this symbol A. So let us move on. So we are going to say C complement N. So it's going to become like this. C complement intersection of C united with C complement N. C complement N, we take this and multiply with this, it's going to be D. So now if you remember those identities, the identities that we looked at in the introduction video, if you haven't watched the video, kindly just go back and check it out, where I've talked about the identities. So let us move on. So those identities, when we when a set is intersected with a complement of itself, it is giving us an empty set. So we replace A with an empty set. This represents an empty set. Forgive the background noise. So we are now going to unite with this remaining part, C complement D. So when an empty set is united with any set, it is going to give us back the set. So here we are going to have this set only. So here the answer is going to be C complement N D. So this is the final answer, just like this. Okay, so we move on to question 7. So they want us to simplify these statements, provided that we have set C and D, and then now here they have said that set C and D are disjoint. What do they mean? They mean that we have two sets. Let's assume we have two sets. Let's say we have two sets. When they say that sets are disjoint, it means they are not attached anywhere. They are separate. Let's say this is set C, this is set C, and this is set D. So now what they mean is that these sets they are not joined together, they are separated. And when this has happened, it means that C intersection D will give us an empty set. When we try to find what is between C and D, what is between A? Nothing, right? That is where an empty set is coming from. So it will give us an empty set. So whenever they say C and D are disjoint, you should take note that while you'll be simplifying, if you reach where you're going to have C intersection D, you should replace with this symbol or an empty set. No matter what, as long as they have said that C and D are disjoint, wherever you're going to have anything that is looking like this, you replace with this. Okay, so now let us solve the question. Let's solve the question. So the first question they want us to simplify this. So now this can't be simplified in any form. It can only be left in this form. So whether you leave it in this form or in this form, it will still be the same. So it can't be simplified. It's not possible to simplify this any further. Okay. So let us go to the next question. So question 2, they want us to simplify C complement D complement. So the moment you see complement written like this, you need to factorize the complement, where you reverse this whole thing. So this can be reversed like this. C, this is going to change to intersection D, and this is going to go outside. So now, as you can see, we have C intersection D, and if you recall, we said that since they are disjoint, wherever we are going to have C intersection D, we are going to put an empty set. So meaning that we have an empty set complement. So now, what is the complement of an empty set? The moment you hear the word complement, meaning that it means that there is a universal set involved. Yes, the moment you see that there is a complement, just know that it is not found in whichever set we're dealing with, but it is there in the universal set, in the other set. So now, here, whatever is not in an empty set, meaning whatever is not between here, it is somewhere else, meaning so now here we are going to have a universal set as a final answer. So we have simplified this. Let's move on to the next question. So question 3, we've been given C intersection D complement. Now as you can see, it is already in this form. So already here we're going to replace with an empty set complement. It is also going to give us E. So that is the final answer. We have simplified it. Let us look at the last question. Question 4. Question 4, which is saying that C united with D complement. When we unite, I mean the union of C and D complement. Now, looking at our scenario here, this cannot be simplified any further. Also, it can't be simplified. It can only be left in another form, but it will still be the same. It won't be left in any simple form. So this is not possible to simplify. So this is how you solve this question. You just need to be careful with noticing whether they have said disjoint, or if they have said that they are subset of each other. If they are subsets of each other, you apply different concept. But if they are disjoint sets, you also apply the concept of if they are intersecting, it means that they are empty. Okay, so that is it for this video. And in the next video, in the other video, we're now going to do more further simplifying. Okay, let us solve more questions involving simplifying. So question 9, let's begin with question 9. So the first question, let me say solutions. So the first question is saying that, this is question 9, they want us to show that, they want us to show that A is equal to A and B U and A intersection B complement. Okay, so whenever you're in a scenario like this, you should always pick the most complicated part, the one that seems to be complicated, to having a lot of sets involved. So now here we are going to get the right hand side. So we're going to say right hand side. So you're going to write it. You're going to write it. Okay, so now we are now going to be applying the concept. So now, as you can see, here we are going to apply the distributivity concept. I mean, the distributivity law, where we factorize what is common. So here, what is common? These two, right? So we are going to factor them out. We are going to factor them out. When you imagine they have been removed, what have we remained with? We've remained with B union and B complement. So we are going to write with what is remaining, B U B complement. Okay, so now remember those identities. When B is united with a complement of itself, a complement of B complement, we're going to have a universal set. So meaning that A intersection universal set. So when again there's another identity that when a universal set is united, I mean intersected with any set, it is going to give us the set that is involved with the set itself. So A, we remain with A. As you can see, hence shown. You just have to show a single side, unlike when you are proving De Morgan's law. Here you just show one side. You just need to pick one side. It's either you pick the left side or the right side. By just doing this, you get the full 5 marks. Full 5 marks. Okay, so now let us solve the next question. Question 2. Question 2. We've been given y complement intersected with x union y. Okay, so now again we are going to expand them since they are different and these are opposite. So this multiplied with this and multiply this with then separated by union. So we are going to have y complement intersection x in brackets, I mean parentheses, and then separated by u. Then we have y complement intersection y. Now we're going to have y complement intersected with x union. Remember, when we intersect a set with a complement of itself, we are going to get an empty set. And then when we unite an empty set with any set, we are going to get back the set itself, right? Okay, so this is how you simplify. This is the final answer, and this is actually question 10. This is question 10. Question 2 of question 10. I made a mistake. So okay, let us continue with the question 9. The questions that are under question 9. So let's go to question 2. Question 2. Okay, so question 2 of question 9. They want us to show that this is equal to this whole thing. So we are going to pick this complicated part. We are going to write it. We are going to say A intersection B united with A intersection B complement united with A complement intersection B. Okay, so now we are going to apply the associativity law property. As you have seen, they have said that we need to apply the associativity property. So now how do we apply it? We are going to gather those two parentheses that are having like terms. So let's begin with these two. These two are not having anything that is in common. B is different, B complement is different, and A complement and A are not the same. But when you look at these two are having A and A, set A and set A, both followed by followed by an intersection. So you're going to group them like this using the associativity property. So you're going to have something like this. So we are going to begin by simplifying now what is inside A. How you're going to simplify this? We are going to reverse them using distributivity property. How do you do that? You need to factorize now what is common, A and intersection. So basically you're going to have this B united with, imagine these we remove them. We are going to remain with B union and B complement and B complement. Okay, so then now we are going to wrap them united A complement and B. Okay, so now as you can see, when you look at what is inside A, there is an identity inside. We say that when a set is united with a complement of itself is equal to a universal set. So we are going to have a universal set. We are going to have A intersected with a universal set union A complement B. Okay, so now again remember we say that when a set is intersected with a universal set, a set itself is going to come back, right? So here we are simply going to have A union A complement intersection B. Okay, now again remember the distributivity property. Since they are like this, we are now going to expand them again. So we're going to expand them, multiply this with this and this with this, then they'll be separated by this. As you can see, it is having three different sets. The moment you just see three different sets, it means that you need to multiply through. So now we're going to multiply A union A complement in parentheses, then they'll be separated by what is A, and then A union B. Okay, so now remember again, we said that when a set is united with a complement of itself, we are going to have a universal set. So here we have a universal set intersected with A union B. Now again remember the identity. When a universal set is intersected with any set, the set is going to come back. So here we have A union B. So this is it. You even get the full 5 marks. This is the simplest form in which you can leave this. Okay, so this is how we solve them. So you just need to be taking note of the where you need to expand or factorize. That is how you apply the distributivity property. That is the easiest way of applying it instead of just mastering it. Okay, now let's solve the last question. Let's solve the last question on question 9. So the last question is saying that given that set A is united with a complement of set A intersected with a complement of set A. Okay, so now as you can see, so they want us to show that this is equal to A union B. Okay, so now as you can see, we have how many? 3 different sets, right? This is a different set and this is a different set. They might be same letters, but for the fact that there is a complement, they are not the same. The moment you just see 3 different sets involved, and the operations that are happening are different. There is union and intersection, multiply through. So now we are going to multiply. By just doing this, it means that you have applied the distributivity property. That's how you get marks. If you want, you can even be writing, before you apply, you say distributivity property. Then you go ahead and multiply this multiplied with this. You're going to have a complement. They'll be separated by this. This multiplied by B. We are going to have A union B. Now remember, we said that when a set itself a set is united with a complement of itself. What do we have? A universal set, right? We have a universal set intersected with A union B. Again, remember we said that when we intersect any set with the universal set, we are going to get back a set that is being united, right? Intersected. So this set is going to come back A union B. This is how we can prove by simplifying. Okay, giving it the full 5 marks. So now we move on to question 10. So question 10, I solved the second question, right? So right now I'm just going to focus on the first one. X complement U Y intersection Z. Okay, so now here they just want us to simplify. So we're not proving anything, we're just leaving these expressions in their simplest form, right? And we need to apply the same distributivity and the associativity properties. So now remember how, again, so the moment you see an expression wrapped into the brackets like this, the square bracket or any bracket, you first need to multiply this through what is inside. So if you are going to multiply this complement with this, remember they cancel, you are going to remain with just x. When you multiply this with a sign, this is going to change. It is going from union to intersection. So you are going to write intersection. Again, here, this is just going to be outside A, and then you are going to have in y intersection z complement. We've multiplied through, we've expanded. So it's all about expanding, factorizing, and expanding. It's just for you to be seen where you need to expand or factorize. So like right now, again, as you can see, as I said, that the moment you see that there's a complement outside some expressions that are wrapped in any form of brackets, you need to expand through. So right now they are wrapped in the parentheses, right? These are called parentheses. Now we are going to expand also. You're going to multiply. So you're going to have x in x intersection. When you multiply through, you're going to have y complement. This is going to change to go to union, and we are going to have z complement. Okay, now we have 3 different values. So now what do? We are going to apply the distributivity property by multiplying through. When we multiply through, we are going to have x intersection y complement separated by union x intersection z complement x intersection z complement. Okay, so now for this question we can't go any further. As you can see, we cannot minimize or replace these with any identity. So you're just going to reverse. You're just going to reverse it in the previous form. So you're going to say x intersection y complement u z. So this is the simplest form, unless we had maybe we had like maybe y and y, we would have done something to simplify this. So now since these are different, we are just going to rewind, or you can either leave E or E, you'll still be marked. So let us move to question 3. Let's move on to question 3. So question 3, question 2 I've already solved. So question 3, it is like this: x intersected with y union x intersected with y complement. Okay, so to simplify this, remember we're going to factorize. This is common, so we're going to say x intersection, we're going to remain with y union y complement. And now remember, we can simplify this, right? We are going to have a universal set. Remember the identities, and when we intersect any set with the universal set, we are going to get back the set itself. So here the answer is simply x. So we go to question 4. Question 4. You go to question 4. So question 4, they want us to simplify this. X union y intersected with x union y complement. Again, we are going to factor out what is common. Xu y intersection y complement. Again, here we remain with an empty set. So x united with an empty set, we're going to get this, the set itself back. Okay, just like this, you have answered. Let us solve question 5. Question 5. Okay, so question 5, they are saying that complement of set x united with x minus z, the difference of two sets. So now we're going to say x complement united with, remember, whenever you have a set difference, you need to know that it's the same as having this set intersected with the complement of this set. Okay, so now since we don't have anything here, we're just going to write it like this. We're just going to write it like this without any square bracket, unless we had a complement here, we would have multiplied through. Now since that we don't have, we're just going to write it like this. Now we're going to expand. It's very necessary for you to expand whenever you reach at this point, in case maybe they can be simplified any further. Okay, so now the x complement union x intersected, we're going to get this intersected x complement union multiplied by z. We're going to have x complement union z complement. Okay, so now recall that when we unite the set with the complement of itself, we are going to get universal set, right? We are going to get back the universal set. So we're going to say universal intersected with x complement union z. Okay, so now we are now going to use another identity, that when a universal set is intersected with any set, we get back the set itself, right? So we get x complement union z complement. This is our final answer. So if you ended from here, you would have received maybe half mark. Even here, now you get the full marks when you reach here. Okay, now let's solve B. Let's solve B. So B, the first question, it is saying that x intersected with a set having x complement united with y. Now remember, if you're in this scenario, multiply through. So multiply this with this, you're going to have x and x complement wrapped in parentheses, then separated by this. Now we multiply this with this, we're going to have x intersection y. Okay, so now remember, if we have a set intersected with the complement of itself, we have an empty set united with x intersection y. So when we multiply it, when we unite an empty set with any set, we get back the set, right? So we have x intersection y. So this is the final answer. Okay, so now let us move to the last question. This is B. This is B. So the last question we have been given x intersected with y complement intersected with x complement intersected with x complement union y. We have this. Okay, so now let us solve. So first of all, as you can see, the whole expression is wrapped inside the square bracket, and there is a complement outside, so we are going to multiply these two. So this multiply with this is going to cancel, right? So we are going to have now, we are going to have x intersection y. It has been cancelled, right? When we multiply this with this is going to change from n to u, from intersection to union. So it's a union. When you multiply this with this, you're going to have x complement union y complement. Okay, so now we are going to expand this. We are going now to multiply this through. The moment you just say that it is outside any form of enclosure, just multiply through. You need to expand. Okay, so now we're going to write x intersection y union x multiplied with the complement is going to cancel, so the complements are going to cancel. Complement multiplied with this is going to change to n, and the complement multiplied with y, we are going to have y complement. Okay, so now we are going to factorize. We have something now that is common. X and n are common, so we're going to factor them out. You're going to remain with y union y complement. Now remember, I said that when you are uniting a set with a complement of itself, you get a universal set. So, and when you intersect any set with a universal set, you get a set that is been involved. So this is our final answer. This is the simplest form. So these are all the questions that they bring on simplifying. They don't go beyond this, in that most of these questions, they just repeat them. They just bring exactly what they've just solved. Yeah. So sometimes maybe they might just change the letters. Maybe where there is x, they might put maybe a different letter, but they want you to apply the same concepts. And they don't go beyond these questions. So this is all you need to know. Once you know how to solve these questions, then you can't fail to simplify any question involving De Morgan's concept. That is it for this video.